Welcome to The Explainer. Today, we're literally pulling back the curtain on how autonomous AI agents actually work. If you've ever found yourself wondering how developers create these large language models that don't just talk at you, but actually do things out there in the real world, like browsing the web or hitting external APIs, then you are absolutely in the right place. By the time we wrap up here, you're going to understand the underlying mechanics well enough to actually start building your very own functional AI agent. So let's get into it.
Okay, so to really grasp this, let's take a second and just think about human cognition. Think about how we naturally use our own inner voice to guide our physical actions, right? When you're tackling a complex task, you don't just blindly start moving your hands around, but you also don't just sit perfectly still and think in a vacuum. You do both. You think, you act, you observe what just happened, and then you think some more. The researchers behind today's source material hit the nail on the head here. They point out that this super tight synergy between acting and reasoning is exactly what lets us humans learn new tasks so fast and adapt to totally unexpected curveballs.
And that brings us to the ultimate question for basically any developer or AI enthusiast out there right now. How in the world do we get a machine to replicate that seamless human workflow? How do we essentially give a language model an inner monologue that actually translates into reliable, dynamic actions, instead of it just spitting out a giant wall of static text?
Well, here's our blueprint for today. We're looking at 1. The AI action gap. 2. Introducing React. 3. How React actually works. 4. Testing the performance. 5. Human-in-the-loop control. And finally, number 6. Building your own agent.
All right, kicking things off with Section 1, the AI action gap. Let's look at exactly why standard language models struggle so much to act independently.
So we've basically been dealing with two heavily flawed extremes in AI agent design. It's kind of been just thinking versus just doing. Over on one side, we've got chain of thought prompting. Now, don't get me wrong, this is fantastic for math or logic puzzles, but it is strictly reason only. It's generating thoughts using entirely its own internal representations, which leaves it totally disconnected from reality. Then, on the flip side, we have act-only models. These agents can interact with environments, maybe a text-based game or a browser, but they're literally just predicting the very next physical action without any high-level abstract planning whatsoever.
The crucial takeaway here is that if an AI only reasons internally, without actually grounding itself in the external world, it is highly prone to severe fact hallucination and error propagation. I mean, think about it. If it guesses a fact wrong on step 1, the rest of its brilliant logic is entirely useless. It's a house of cards. And conversely, if it acts without reasoning, it can't keep track of its sub-goals or pivot when things inevitably go wrong. It's just blindly clicking around hoping for the best.
So, how do we fix this? Let's move to Section 2. Introducing React. This is a totally new AI paradigm that completely changes the game by bringing those two isolated capabilities together. I love this because it brilliantly illustrates the concept using a simple kitchen analogy. Just imagine you're cooking dinner. You use reasoning to track your progress, right? Like, okay, now that the veggies are cut, I should probably heat the water. Then you inevitably have to adjust your plans. Uh-oh, I'm out of salt. Guess I'll use soy sauce instead, assuming, my guests don't mind salty soy sauce water. And crucially, you use actions to support that reasoning, like literally walking over and opening the fridge to see what's inside. You absolutely need both to cook a meal.
Enter React. So React is essentially a prompt-based paradigm that prompts large language models to generate both verbal reasoning traces and actions in this beautifully interleaved manner. By mashing these two modes together, React allows the model to reason to act, which means creating and adjusting high-level plans, and act to reason, which is interacting with external tools, like, say, a Wikipedia API, to pull in fresh, accurate data. That way, it updates its knowledge dynamically on the fly.
All right, Section 3, how React works. Let's look under the hood and see how this actually builds a functional AI brain.
It boils down to this really elegant 3-step loop, which is the core engine of React. We're literally forcing the AI to interleave its process. First, it outputs a thought, where it reasons over its current context in plain, everyday language. Second, it outputs an action, calling a specific tool or API. And third, the external environment spits back an observation, which is then fed directly back into the model. Think, act, observe. Wash, rinse, repeat, over and over until the task is completely done.
To put that into perspective, let's look at a really complex task like Hotpot QA. It's a benchmark for answering tough, multi-hop questions. Here we can see exactly how this plays out. The AI formulates a search plan in its thought, it acts on it by pinging a Wikipedia API, and then it reads the observation returned by that API to course correct. The coolest part? If the search comes up empty, the AI doesn't just confidently hallucinate a fake answer. Its next thought is literally, well, that didn't work. Let me try searching a different term. It's so amazingly human-like.
Moving on to Section 4, testing the performance. Because, it sounds amazing in theory, but does this actually work better than standard prompting when we look at the hard data? Well, check this out. When the researchers manually analyzed the failure modes, the contrast was honestly staggering. When standard chain of thought prompting fails, a massive 56% of the time, it's simply because the AI hallucinated facts. It just totally made things up. But with React, that hallucination failure rate drops to an astonishing 0%. Literally zero. React completely eliminates hallucinated facts as a failure mode simply because it actively verifies information externally before making any kind of claim.
And when you combine React with a technique called self-consistency, it scales this performance even further. By looking at the accuracy on the Fever Fact Verification benchmark, you can see that the React model, because it relies on externally retrieving rock-solid knowledge, consistently outperforms those reasoning-only models. Basically, when the model realizes it doesn't know something internally, it just seamlessly backs off to React and goes out to fetch the right answer from the outside world.
And the results are honestly even crazier in interactive decision-making tasks. When they applied this to environments like AlfWorld, which is this complex text-based game simulating a household, React outperformed state-of-the-art imitation learning methods by a massive absolute success rate of 34%. And get this, it did all of that while only needing like 1 or 2 examples in its prompt.
Incredible.
Okay, Section 5, Human-in-the-Loop Control. Let's uncover what I think is one of the most powerful and maybe unexpected side effects of this entire framework. Because the AI is constantly printing out its inner monologue in plain English at every single step, it is incredibly interpretable. You aren't sitting there scratching your head guessing why the AI suddenly clicked a certain button. You can literally read its exact thought process. This means you can immediately spot the exact moment its logic derails, which opens up this entirely new, super intuitive way for humans to collaborate with AI.
So here's the real game changer. You can literally edit the AI's thoughts on the fly. The researchers highlighted an example where the AI got totally stuck looking for a keychain. By simply jumping in and editing the text prompt midway through the task, like literally just tweaking the thought text to nudge it to look in the safe, a human can instantly redirect the agent's behavior. You don't need to rewrite a single line of code or retrain the whole model. You just politely correct its inner monologue, and the AI immediately adapts its very next physical action. Which brings us to our final section, number 6, building your own agent. Let's look at how you can take all of this and actually build something right now.
If you're building a tool today, React is absolutely the ideal architecture to start with. Why? Well, it's just so intuitive to design. It requires zero ad hoc formatting. You just have human annotators type out their thoughts in plain language right on top of their actions. It's also super flexible across totally different domains. You could build an agent for fact-checking or one for web shopping, it doesn't matter. It performs incredibly well with just a handful of examples, and as we just saw, it allows for that awesome direct human control.
And the best part is, you don't need massive compute power to get started. To build your own agent, you really just need to prompt your chosen language model with a few solid examples of interleaving thoughts, actions, and observations. From there, you connect it to the real world using an MCP, a Model Context Protocol. You can think of an MCP as like a universal plug-and-play adapter for AI. Instead of pulling your hair out writing custom code for every single tool you wanted to use, the MCP gives your React agent standardized access to search tools, your internal databases, or even your local files. You just hand it the tools and prompt it to reason out loud before it acts.
So now that you understand the mechanics of synergizing reasoning and acting, you officially have the blueprint to bridge the AI action gap. You know exactly how to ground language models in reality, eliminate those pesky hallucinations, and create systems that can autonomously navigate really complex environments. The only question left for you is, what real-world problem are you going to have your brand new agent solve? Thanks so much for joining us on this explainer, and we'll catch you next time.